This is the way how we present the data. What our main focus is to see where is our plant losing power, where could it generate more. So we have identified 3 areas. One is underperforming modules. At this case, we're losing 5.5%. And soiling, where we're losing 3.9%. And we have shading, where we lose 7.1%. So all those data is automatically generated from our artificial intelligence system, and it requires, of course, an irradiation sensor, high quality, and the rest is done through our system. So those 3 factors we're concentrating on, and the key for increasing yield from your plant is to have a certain structure how you will work on it. For example, here, if I look for underperforming modules, it is important to display for us on a preview how many modules are really outside of warranty. That means, well, actually inside of warranty, but outside of warranty specs. Those are the ones. And those ones are producing less energy than they should from the spec sheet. So let's click onto this and dig this a little deeper. So this is the power we lost. You saw on the right hand how much energy or how much cost or opportunity cost it is, what you're losing. So for example, here's the warranty line, and that's dynamically calculated. You can add this, and if you deselect, for example, some, so you see where are the modules located and how much you gain here per month if you change those modules. Those are the modules, again, they're out of warranty specifications. That means they can be replaced free, at least for the modules. And now we need to calculate, does it make sense to swap them? Because this is the next question you have. We have asked Albert for the specification. And there you see the modules again with the power loss, and as you can see, it's above 10%. And what we have a cost setting underneath. You can put some cost settings here. For example, labor would be, for example, it's been put in total 250. And transportation, it's for example 50. And if there would be new modules, you would put new modules in here. So anyway, that is the setting. You always can add more pricings for it, either for the whole plant or for each module. So anyway, this has probably been set up. And now you see, for example, replacing those, your ROI is in 4 years and 5 months. So that's approximately 27, 28%. Actually, no, it's 22% interest rate on the money you pay for repairing or bearing the cost for changing those modules. Now we want to generate a maintenance plan, and in this maintenance plan you see the modules, they're all being listed. This is being given to the installation company, and they know immediately which one they have to swap. So this is the way we look at things. If we go back, a similar way we do soiling. We cluster them in loss classes, and the red line shows when it makes sense to clean. Well, that's still under the line. This is still good. You see this, it was dropping here in Germany in April. We had a lot of rain, so they cleaned by themselves. Nice. Some countries you don't have this, so you would display them here. And in parallel, there's no data now because we didn't do any cleaning. We would show you when it was cleaned, how good the cleaning job was done, because we see what the efficiency was, 60, 80, 100%. We see this very nicely in this presentation. Same for shading. So we differentiate between recoverable and unrecoverable. And of course, we have the degradation for the whole plant, for example, is 0.4. It's quite high. You can, for example, what are the single strings are having for degradation of the module of the strings, but you can then click into the single modules, and as you can see here, this is 0.43. This is a very good module with 0.14, at least recently. So we're displaying all the necessary information for you to run the plant and have actionable feedback on it. There you have the calculation, what you lose over the, for example, here the end of the PPA if you do not swap those modules. Oh, that's pretty interesting. So going straight to the main information you need to run and manage your plant professionally. This is what SunSniffer and its digital twin technology is about. Thank you very much. Hi, this is Ingmar Cruz. I'm the CEO of SunSniffer. I'm talking about the hardware requirements for actionable analysis. The key to get good analysis from your PV plant is not only having a good software with all the analytics and artificial intelligence, it's about what do you pick up from the field. And what we have developed a special hardware which picks up 3 different levels from the field. One is on module level. This is this here. We pick up data from module level. We pick up data from string level. And we have our own gateway, taking all this information, aggregating it, taking inverter information as well as irradiation, and sends them to the web portal. Okay, now, but the key to get inside information of a PV plant is to have the module level information available. And we developed 11 years ago an operating system for solar modules called SunSniffer OS. And we have put this into a little microcomputer, very, very small, with a little sensor. Altogether, it fits into a junction box. It doesn't change the energy of the module. It is measuring it and sends the data via existing DC cables to our string readers. That means from here we measure those data, we measure this voltage and temperature, send it through the existing DC cable to the string reader. The string readers are measuring voltage, current, and having an energy meter, and they pick up the data through a PLC, a DC line PLC, and send it via RS485 to our gateway. And that all together sends it to the portal where we have our analytics based on our digital twin system, and gives us results which are actionable. That means it shows you which modules are degraded, which are soiled, how much they are soiled, and how much your modules are shaded. So thank you very much for listening.